We are going to use the following picture to try to understand the differences between positive and negative work and what that really means. So let's say here's what we have. Have a ground, some box, give it mass M, moving this way, all right, with these forces acting on it. A pulling force F, friction force Fk, normal force, and the weight of the object. So what we will do is look at the work done by each of these forces as this box moves along the floor this way, some distance delta x. So let's try to analyze it. So to figure this out, we're going to look at the work done by each of the forces. So here's the first one. Let's look at 1F, the work done by the pulling force. Formula, work equals F cos theta delta x. So the work done by the force F, well, the force is F. It moves delta x. The angle between F and delta x, they're parallel to each other in the same direction, 0 degrees. So you find out the work done by F, since the cosine of 0 is positive 1, is a positive F delta x. Again, we're not worried about the numbers, we're looking at the signs. So let's think about what is happening. The force F is acting in the direction of motion. The force F wants to speed the object up. I didn't say it does speed the object up. We don't know if the object is speeding up, slowing down, or moving at a constant velocity. There are other forces on the object. We can say that the tendency of F is to speed the object up. The tendency does not mean is what it's doing. It's what the force wants to do. So, if a force does positive work, it tends to speed the object up. Tendency. Once again, tendency does not mean is speeding the object up. So that's what positive work does. Any force that does positive work wants to speed the object up. Let's look at Fk now. Okay, work. F cos theta delta x. So the work done by the friction force. The force is Fk. The object still moves delta x, but look at F, K, and delta x. They are 180 degrees opposite, as always the case with friction. That is the angle between Fk and delta x. The cosine of 180 degrees is negative 1, so the work done by F is negative Fk delta x. Look what Fk tends to do. Friction, or the tendency of Fk, is to slow or stop motion. So, it does negative work. So, if a force does negative work, it tends to slow the object. Once again, I don't know if the object is going to speed up or slow down. I do know that Fk tends to slow motion. This is what negative work is. Let's look at N and mg, and we can look at them together. Both of those, if you look at the angle, the relative angle between N and delta x and mg and delta x, they're perpendicular to each other. So N and mg, the angle between N and delta x and mg and delta x is 90 degrees. Perpendicular to motion, the cosine of 90 degrees is 0. So when you look at the formula, the work done by N and mg, 0. This goes back to the original concept. N and mg do not help or do not hinder the motion of the object. Therefore, N and mg do 0 work in moving the object delta x. So in summary, if a force does positive work, it tends to speed the object up. If a force does negative work, it tends to slow the object. In the next video, we will analyze the same picture, but talk about the net work done.